Welcome back to Chapter 6 of the JavaEE course, and a big change this time, we're going to be getting started with JPA. It's probably worth, before we start this chapter, having a quick review of the architecture that we've built so far, and then we'll go on to look at what JPA is. Of course, we're going to need a database in order to do anything with JPA, so we'll look at how to install one. And then the two important topics in JPA are domain classes and entities. By the end of this chapter, we'll have created data in a database. So at last it's time to address a big topic that has been looming large over us since the start of the course, and that's the database. Now before we start, I'm going to review the architecture we have built so far on this course. I must remind you, there are many different ways of architecting systems, and there's no such thing as a best way, and the structure I'm using here is just one of them. But it is a very common style of development on JavaEE projects. We have a client tier, which for us so far has been a very basic standalone Java application running off the server. We've been using remote method invocation to prove that we can make network calls to the server. But in later chapters, we'll be changing this for the more common web front end. The client is accessing a server-side service class, and we've called this employee management. Remember, the idea of the service is to present a high-level view of the system functions to the clients. So we have very recognizable method names in here like get all employees, record note against employee, and register employee. In a real application, there would be more than one service class, and this collection of classes forms the so-called service layer. And we've implemented this as a so-called stateless EJB. In order to do any work, though, we need to retrieve data from the database and to turn them back into regular Java objects. This is the job of the data layer. This will be a collection of data access objects, or DAOs. These are simple classes that enable us to read, write, update, and find objects in the database. Notice that I've deliberately used different method names in this class to the method names on the service layer. The service layer is a higher level of functionality than the data access layer. This DAO layer is going to be the focus of the next few chapters, as we're finally going to implement a real data access solution. There are two main libraries for doing data access in Java. Firstly, there's JDBC. You may have used this on your previous Java work. This is effectively a mechanism to allow you to issue SQL statements to any database that supports Java. JDBC is okay for some purposes, but it is very low level and requires a lot of tedious code to transform the rows of data from the database into collections of Java objects. JDBC is really standard Java, and so we don't need to study it on this course. What we're interested in for JavaEE is the library called JPA. This stands for the Java Persistence API and is a new standard that was introduced back in JavaEE 5, so relatively recently. Now, put simply, JPA will allow us to work with Java objects, and I mean regular Java objects, and the JPA library will automatically, or at least with a little bit of effort on our part, it will create the SQL needed to reflect our changes in the database. So imagine I have a Java object in memory. When I make changes to that Java object in memory, as I would normally do in Java, at the appropriate point, JPA will detect the change to that object and will automatically issue an SQL update statement. Now, it's not quite as magic as all that. We are going to have to do some work to make it happen, but essentially, that's what JPA will do for us. Now, before we start coding, I want to do a quick history of data access in JavaEE, as there is a lot of conflicting terminology in this area, and much of it is historic. Back in the earliest days of JavaEE, there was a part of the enterprise specification called entity beans, and these were Java classes that were capable of being automatically persisted in the database. This was present in J2EE from versions 1.2 to 1.4. It's a long story, but entity beans were extremely badly implemented. They performed badly, and worst of all, you needed to make extensive changes to your code to accommodate them. So they gave JavaEE, or I should say J2EE, a bad reputation for a long while. But then in the early 2000s, around 2002, 2003, a software developer called Gavin King decided he would invent his own system of persistence. Effectively, he aimed to improve what entity beans had done so badly. He called his library Hibernate, and I'm fairly sure you will have heard of Hibernate at some point in your career. Now, the key thing about Hibernate was you had to make minimal changes to your classes, and yet you would still get the same results as entity beans. And oh, it performed pretty well also. Now, I can't underestimate what a massive success Hibernate was. It really felt like every Java project was using it. A possible problem with Hibernate was that it is non-standard. It's not part of the JavaEE spec, and it's effectively a tool developed by one group, and that happens to be JBoss. It is open source, but it was definitely a concern for some people that such a powerful library was controlled by one company. But then two things happened. Firstly, the JavaEE committee realized that their work on entity beans was really poor. So for JavaEE 5, they decided to take on the principles that Hibernate had established. And in fact, the creator of Hibernate, Gavin King, was one of the main people behind the improvements in JavaEE 5. These improvements to persistence were given a new title, JPA. As I've mentioned, this is the Java Persistence API. And this is the new official standard for persistence. But given that Gavin King and his associates were very closely involved with the development of the spec, you can almost think of JPA as being a standardization of Hibernate, because it really is based very heavily on Hibernate's original API. But as with most Java libraries, JPA is just a specification, and many groups are free to implement this specification. And so what's happened is there are at least 3 major implementations of JPA that you can choose. You could go for Hibernate, which remains a leading implementation of JPA. So many projects who say they're working with Hibernate are actually these days using JPA. So it's actually possible that you might be asked in the future if you know Hibernate, and actually you will, because you will have learnt JPA. But as I say, other vendors are now free to come up with implementations of JPA as well. at the time of recording, apart from Hibernate, there's also Eclipse Link. This used to be called Top Link and originated from Oracle. And there's also from Apache the Open JPA project. So as always in Java, you can choose any of these three implementations, and they may perform differently, but they all work in the same way with the same API. So when you acquire a JavaEE server, you'll find that the server ships with one of these three implementations. If you're working on JBoss, for example, you'll be using Hibernate under the covers. But with Glassfish, for this course, the implementation is Eclipse Link. But I must stress it's a standard API, so it doesn't matter which implementation you're using, it's all just JPA. One of the really wonderful things about JPA is that we don't have to run the code on the server to make it work. We can also write standalone JPA that simply runs from an Eclipse project without needing to be deployed. So my plan for this course is we're going to leave Glassfish for the next few chapters, and we're going to look at JPA on its own just inside Eclipse. This will keep things simple and stop us getting stuck on unimportant matters. Then, when we've got our JPA code working, I'll show you how to integrate your JPA into Glassfish. And when we've done that, we'll have built a professional standard architecture. Now, of course, we're going to need a database to be installed. You might already have one installed, say MySQL, Oracle, or whatever. Now, if that's the case, and you know the database URL and the driver name, and you have a jar file for the driver available, then you can skip the next few minutes where I'm going to install a new database. Well, if you're still with me, I assume you don't have a database available and you want to install one. Well, there are lots to choose from in Java. You could work with any of them, but I've decided to use a database from Apache called Darby. This is actually an open source version of a very long-standing database called Cloudscape. It came from IBM. You can find the site at db.apache.org, but you don't need to download this from Apache because I've included a copy of the distribution in the Practicals and Code folder for this course, under the folder called Software. You'll find Darby in there. It's the zip file that I'm showing you here. It's really easy to install. Just unzip that folder to somewhere on your hard drive, and then you're done. That's all there is to do. Earlier on, I unzipped Darby onto the root of my hard drive. As I say, it doesn't really matter where you put it. Inside there, you'll find the usual folder structure, and the main one we're interested in is the bin directory. And all the tools you need are here. Now, there's lots of different ways of running Darby, and if you check the instructions on the Apache Darby site, you'll find there's lots of references to setting environment variables and so on. But I think I found a slightly easier way of working, and that would be if you fire up a command prompt. If you're using a Macintosh, Linux or Unix, then you can do this from a terminal window. And simply navigate to the directory in which you've just installed Darby, which for me was the root of the hard drive and the db Darby directory. Then go into the bin directory, and I'm now going to run from that folder the script file called start network server. Now, this will only work if you've installed a Java development kit on your machine, which I assume you have. When I run that script, you should see the logging ready to accept connections on ports, and there'll be a port number appearing there. Now, it's always difficult when making video courses. I always worry that you might have a random crash or something happening here, so please contact us on our contact address if you have any problems, and we'll help you proceed. But I'm sure if you follow the steps, I hope it will have worked for you. Now, I'm just going to leave that window running in the background for the duration of my work. I'm now going to fire up a second command window. And what I'm going to do here is I'm going to make sure that the database here is accepting connections. I'm going to go into the Derby directory again and into bin. And this time I'm going to run the script file called IJ. I'm not entirely sure what IJ means. I think it might be interactive JDBC. Now, what this tool allows us to do is it allows us to issue SQL statements against the database. Now, what you need to do is to connect to the database first of all. And to do that, we're going to use the command connect. And then the syntax is rather awkward. You have to use a single quotation mark and then the following long string. JDBC : Derby : localhost : 1527. Now this is just the address of the machine in which your database is running. Localhost means this machine, and 1527 is the port number that we saw there. Then, after a /, we're just going to name the database. Now for us it's the employee database, but we haven't already created this database, so we're then going to use ;create equals true. That will tell Derby that it needs to create this database. Then I'm closing the quote mark and then a semicolon on the end. It's a rather awkward string that. I'm going to put that in big letters on the screen now so you can pause the video if you need to copy along. When you've entered this string, I'll hit return, and then the fact that the command prompt has returned without an error means I'm now connected to my new database. I could now start issuing SQL statements like create table, drop table, and so on. Now, to make sure that the database is working, I'm going to issue a couple of SQL statements. Now, I've no idea if you already know SQL. You don't really need it for this course, but it will help. To check the database is okay, I'm just going to create a quick table using create table. I think I'll call the table just temp_table. I'll add in an ID column and I'll give it the data type of an integer. By the way, you always need semicolons on the end of each statement in this IJ tool. And that looks good. No errors, and it's saying there were no rows inserted as a result of that command. I'll now insert into temp_table. I'm going to be passing in the ID values. Let's put in the value 5 into that table. Looks good. One row inserted, and then I'll do select star from temp_table, and there's my table populated with a value. You don't need to bother doing that if you don't want, but it's a bit of a sanity check to make sure that we have a working database. Well, before long we'll be seeing proper data appearing in this database, but now I think it's time to write some code. When I'm talking about JPA, I'm going to talk a lot about domain classes. Now, a domain class is a class in our system that represents the actual real-world objects that we need to deal with in our system. And all good object-oriented systems will have domain classes. These are usually the nouns in your design, like user, product, cart, customer order, and so on. And for us, the biggest example on our practical work is the employee class. Now, since domain classes often need to be stored on a database, that's why they're important to us in our JPA work. So let's have a look at the employee class, and I hope as a Java developer there's nothing in here that you find difficult. A regular class, we have a collection of attributes, in our case 3 strings and an integer, but it could have been anything. And then we have a constructor, and for us we've decided to accept all 4 parameters into the constructor. And then very importantly, there would be regular methods in this class. Now, as I haven't gone very far yet with the design, I don't really have any interesting methods in this class, but in an object-oriented design, I would have methods in here to implement business logic. For example, I might have a routine in here that calculates a bonus for an employee based on their salary and job role. Now, what I want to get from JPA is the ability to be able to create instances of employees and to somehow get them in the database with the minimum of effort. So, what do I need to do to make this class be usable by JPA? Well, in the earlier days of JavaEE, when it was called J2EE, we'd have to do an enormous amount of work to this class. We'd have to make it abstract, we'd have to add additional methods, and all kinds of horrors. But in modern JPA, all we have to do is we add the entity annotation at the top of the class. Secondly, we need to make sure that there is a no argument constructor, as I'm highlighting here. This doesn't affect our existing constructor. We can still use that as before. This no argument constructor is for JPA to use. In fact, JPA will use this when it's bringing back data from the database and it's creating new instances. And thirdly, perhaps this is the only slightly difficult thing that we need to do. We need to determine one field that JPA can use as an ID. This ID is used for JPA's housekeeping purposes, and it will usually reflect the primary key in the database. Now, my existing class has 4 attributes: first name, surname, job role, and salary. Now, none of those 4 fields uniquely identifies instances of employees. So what's very common when working with JPA is to introduce an extra field representing the ID of the class. Naturally enough, I've called this field ID. Now, I've decided to make this an integer. I've added 2 annotations to this field. The ID annotation is required. That tells JPA that I want this to be the ID attributes. The second annotation is optional. The generated value annotation tells JPA that we're not going to put any values into this field. Instead, we're going to let the database automatically generate these values, and they'll be populated from the database. The strategy equals generation type.auto is asking for the auto generation of IDs. Now, when you go a little further with JPA, you'll see there are a few advanced options that you can add into there, but for most purposes, the auto value is what you need. And that's all we need to do to make this class be usable by JPA. And notice that none of these changes damage the class in any way. It still remains testable. It really doesn't change the behavior of the class at all. And I really want to remind you that the regular Java methods that we would have in here, like my example of a method to calculate the bonus for an employee, would be completely unchanged. JPA is not invasive. It doesn't really affect the design of our class. By the way, before I move into Eclipse, I should mention that the phrase entity has indeed been inherited from a very early version of JavaEE, but because the annotation is there, a lot of people will refer to this class as being an entity class. Now that's fine, but I really want to emphasize, I can't emphasize enough, that the presence of the attribute really doesn't change the feel of the class. It's still a regular Java class. Anyway, enough talk. Let's get this into Eclipse. So it's a very warm welcome back to Eclipse. I hope you're following along with me on these practicals. And remember that we have a package in our design called domain. And inside there is the employee class that we created earlier. We haven't really given it much attention so far. But there it is, and it's pretty much the same as on the caption, apart from there is a toString method in there. So following the steps as on the caption, to make this usable by JPA, I'm going to add in the entity annotation. That will need to be imported, so my usual Control-Shift and O has automatically added it. Do double check the annotation, it will be the javax.persistence annotation. The second job is I need to add in a constructor. We often call it the default constructor in Java. I'm going to call it the no argument constructor because I think that's a little bit clearer. We're not going to be calling this constructor in our code, so it's fine to make that constructor be blank. I suppose I ought to align those curly brackets a little bit more. In fact, I'll add a comment in just to be clear. Required by JPA, but not used by us. And then step 3, perhaps the only difficult one, I'm going to add in an ID field, largely for JPA's internal housekeeping requirements. If you have a field that is a naturally unique field, then you could possibly use that field, but generally we advise it's cleaner and simpler if you introduce almost a dummy field, sometimes called a surrogate field, and we need to annotate it with the @ID annotation. Again, I'll import that, and checking the import, there it is. Now, if I were to leave things like this, then JPA will assume that I'm going to generate in the code the values for the IDs. But really, when we have a database behind us, we probably wouldn't usually be doing that. So I'm going to use the generated value annotation as well. Now, it's a bit of an awkward one, this, that we also have to specify the so-called strategy. That is equal to, and what you do is you specify the strategy from the generation type class. And when I hit the dot, I mentioned briefly on the caption, there's 3 other values you can add in here. That's identity, sequence, and table. And what therefore is, if you have a specific way of generating IDs that you want to force JPA to use, then you can use one of those 3 options. I think you'll find on most projects, auto works just fine. That's basically saying to JPA, just use whatever is the best strategy for the database that we happen to be using. Again, a Control-Shift-O to bring the generated value into view. And I also have a typo on strategy, which I always seem to misspell for some reason. And there we are. We've now got to clean code. And really, it still surprises me that that's all you need to make your class usable by JPA. Now, it's really important to realize that just adding these annotations doesn't actually make the class be persistent. Let me explain. I'm going to write a test harness. And inside this test harness, I'm going to create an instance of the employee. And I'm going to see if it goes into the database. So my class will be called Test Harness. And I think I'll just add this into a package called test. and it's going to be a very, very simple class, this one. Let me just remove the auto-generated cruft that Eclipse has added. Now inside this harness I'm going to create an instance of my employee. Let's call it employee1, and into the constructor I think we need the first name and the surname, and job role can be engineer, and salary can be any integer, and Control Shift and O to import that particular instance. Now if I run this code, well, nothing's outputted, and I don't think we expected anything to be output. Just switching across to my command prompt that we worked with earlier. This is the command prompt that has the IJ tool running. I can use the command show tables. Don't forget the semicolon. And well, there's a lot of tables listed there, but actually they're all the system tables. They're the ones preceded with the SYS prefix. And there's also the temp table that I created earlier. Oh, and there's a temp table as well. That's just one that I created during my rehearsals for this chapter. So it doesn't appear that anything's changed on the database. I don't know if you were expecting that or not. I said in the introduction that JPA is automatic. Well, what I really mean is that the SQL is automatically generated, but only if you make it happen. You have to touch the object to tell JPA that it needs to do its job. In fact, we're going to have to add quite a lot to this test harness to use JPA. So I'm going to go to a caption for a few minutes just so we can see what's needed. So on this caption, I've expanded my test harness to show you how we're going to make this object become persistent. I must warn you, there's quite a bit of code here, but most of it is very routine. It's almost copy and paste code. You're going to see in a later chapter that when we move this code onto Glassfish, most of this code will go away. But let's have a look at the test harness. First of all, right in the middle of the code, there is my line of code where I have instantiated my employee. That's not going to change. But if you like, I've wrapped some code around the creation of the employee. The really important line of code for me is the one that I'm highlighting here. On this line of code, I'm creating an object from the Entity Manager class. Now, the Entity Manager class is the central class in the whole of JPA. If you think of it as being the interface to JPA, then you won't go far wrong. Whenever I want to create objects and delete objects and find objects, I'm going to be calling the Entity Manager. I've called the object EM. Now I know it's not good style to give your objects short names, but you're going to find that almost everybody in JPA calls the Entity Manager EM. It's just one of those conventions. Now a slight complexity is you can't instantiate the Entity Manager yourself. It's one of these complex objects that needs a lot of configuration. You use a helper object called the Entity Manager Factory. And the way you create the Entity Manager Factory, well, this is a bit tedious as well. You use a helper method called Create Entity Manager Factory. It's from a class called Persistence, which is a very basic class. You'll only ever see it used here. That's a class responsible for bootstrapping the whole of JPA. I'll talk about what this string is in a few moments. It's not a really very important string, but I'll tell you what that is in a short while. Now, the next thing to understand is when working with JPA, we still have to handle transactions. Now, some of you will be familiar with database transactions. If you are, then suffice to say that we're still going to begin and commit transactions as you would have done when working with a database directly. If you don't understand transactions, then don't worry, we have a chapter coming up where we'll talk in great detail about transactions. For now, you need to access the current transaction using the getTransaction method, and you need to call the begin method in order to start a transaction. The next line of code, well, you've seen that, that's where we've created the employee, and nothing has changed there at all. Well, now for the big line of code, the persist method, which I'm calling from the entity manager, is telling JPA that the employee1 needs to be persisted in the database. JPA will now mark that object as being a persistent object and will do the necessary work to make it live in the database. We're going to need to talk in some detail about exactly how that works in a short while, but for now, it marks the object as being a persistent object. As long as we remember to commit the transaction, then JPA will automatically generate the insert statement to make the object be live in the database. The final step, and this is a housekeeping step really, is that when we finished with the entity manager, we must remember to close it. Again, more details will follow later, but this is going to do things like releasing any memory that the entity manager is using. There is a lot of code there, but as I've said, there's nothing very complicated here, and you're going to see in a later chapter that Glassfish will remove a lot of this. We just need it when we're doing things on a standalone client. So here we go then. I am going to type this longhand just to make sure that you're following along and are happy. Of course, you could forward wind past my boring typing if you don't want to see it. The steps are always the same. We start by setting up the Entity Manager Factory, and I'm just going to call it EMF. We never use it beyond the next line of code, and it's always created by using the persistence class, which I think I've misspelt. Let's try that again. And the method we're looking for is the create entity manager factory. The one parameter it takes is a string. Now, I promised I'd tell you what that means in a moment, but it really can be any string you like. I think I called it employee DB on the caption. More on that shortly. Control Shift and O to get my import in place, and you'll see that all these imports are from javax.persistence. Now that's just really a step along the process towards creating my entity manager. This is the big class. We instantiate that by calling the entity manager factories create entity manager method. Control Shift O to import. Okay, good. The next step is to access the transaction. And a common mistake here is you must use the entity transaction class. In fact, in an earlier rehearsal for this chapter, I accidentally used the transaction class there, which is from a different package and relates to a completely different API. Very painful mistake. And I'm going to call it TX, and you access it via the getTransaction method on the getTransaction method, there it is, on the entity manager. Again, that will need an import, and always double check the import there. It does need to be from the persistence class. And then the final routine step is tx.begin. Okay, so the creating the employee remains completely unaltered, and all that remains is to call the persist method on the employee object, or rather we're passing the employee object in as a parameter to persist. That's going to make the object be persistent, and then we just need to commit the transaction. It's a common question on my live courses. is this actually needed, the commit method? Well, it really is, because without the commit method, the changes are not going to reach the database. An important final step is to remember to close the entity manager. So any resources that the entity manager has been holding will be released. Now, we're not quite there yet. This isn't really runnable. Just to be dramatic, I can try to run it, but I know it's going to crash. So there's the crash. And I think you can probably guess by now that the exceptions in JavaEE are not particularly helpful. It's saying no persistence provider found for entity manager named employee DB. So what's going on here? Well, what's happening is whenever we work with JPA, we need to set up a properties file. This properties file is going to contain all of the configuration information that JPA needs. Well, if you think about it, we haven't told JPA where the database is. So we're going to need to do that. So this is the final boring step we need to follow. We'll go to a caption and have a look at it in some detail. Now, the properties file that we need to set up must be called persistence.xml. That's part of the standard. Don't freeze the video and start typing this in right now, because I'm actually going to give you a predefined version of this file to save you typing, because as you can see, it's a rather fiddly file to work with. Especially right at the top, there's a very big schema definition. Apart from that, the next step is to set up the persistence unit tag, and the name that we specify here needs to match the string that we specified in the test harness. If you remember, I called it employee DB. The reason for this string is just in case you had multiple databases that you needed to access in your application. Then you could use that string to resolve it. But really, that would be quite an advanced operation to do. So we just need to make sure that that string matches. Then, inside this properties tag are really just the boring routine properties that JPA needs to find your database. Firstly, we need to specify the driver for the database. Now for us, that's going to be org.apache.darby.jdbc.clientDriver. If you're using a different database like MySQL, you'll need to find out what the driver name for that database is. Similarly, the second property is the URL of the database. And we know what this one is. Do you remember when we were working with the command prompt and we specified which database to connect to? Well, the string here is almost the same. I'm using here JDBC, Derby, localhost 1527, and then my database name. Notice I don't need create equals true this time because I've already created it on the command line. Then we need to specify the username and password, and it turns out that the default username and passwords on Darby are app and app. Of course, in a production environment, we'd need secure password setting up there, but they're the default ones. And then the next three properties are specific to Eclipse Link. Remember, that's the implementation of JPA that we're working with. These are things like, do we want Eclipse Link to write logging to the console? Well, you're going to find out that yes, we do, because we need to know what JPA is doing. And so I've used the reference manual, and it turns out I can set the value fine to give me fine-grained logging. The next property I've set is the DDL generation property. This is a very clever property. What this will do is it will create the tables for me. Now, of course, that's not very good in a production environment where you'll probably already have a database set up. But when we're working in a test environment like this one, this is great. It means we don't have to fiddle around creating all of the tables that we need to support our Java. The second of the DDL generation properties is just telling JPA to actually physically execute the create tables on the database rather than just printing out the SQL that is needed to do so. Well, back in Eclipse, I really didn't want you to have to type in this code for yourself. So you'll find if you have a look inside the meta.inf folder under src, there's already a file called persistence.xml, and that looks exactly what was just on the caption. A couple of things to notice. First of all, the config file must be in a folder called meta.inf. That's just a strange aspect of the specification. It's just one of those things that you have to do. The only thing we need to change in here is the your name here must match the string that we used here on the client. So we call this employee DB, and we need to change that right there. I think we nearly have everything in place now. Let's go for another run. We'll go back to running our test harness. Well, we definitely got a lot of logging there. Let's have a look at what we found. I can see from the logging that this doesn't look too bad. We appear to be getting a connection based on the logging I can see there. By the way, I didn't add a jar file for this driver, and that's because Java actually ships with an implementation of Derby out of the box. Again, if you're using MySQL or any other database, you would need to add the driver jar file to your class path. But that's a digression. Here's the exception down at the bottom, and it's saying employee Mark Briggs is not a known entity type. Now, this is just a minor little bit of configuration. When we've got a entity class, there is one further step we need to carry out, and that is we need to add it to the persistence.xml file. It doesn't go in the properties list, it goes before properties, and it's via the class tag. All you need to do is supply the fully qualified class name of the, in our case, the employee class. So com.virtualpairprogrammers.domain.employee. Now, I could have done that for you in advance, but I was a little concerned that you might have changed the package names. So I wanted to absolutely highlight that you do need to add this class into the config. Let's run that again. And it looks like I have the same exception actually. In fact, I think I've just misspelt. Yes, the package is actually virtualpairprogrammers.staffmanagement. So it's a little bit annoying that, as you can see, it doesn't check that these classes actually exist when it's parsing the XML file. So if you have any similar problem, always make sure you've typed this line in correctly. And actually, just as I've been lecturing you about typing incorrectly, I've just realised I've spelt my company name incorrectly. That should be Virtual Pair Programmers on there. So I'm glad I spotted that before running again. So, okay then, we'll rerun the test harness. Okay, well, oh, there's more. Lots of logging going on here. There is some red text up there, and similar to earlier on in the course, this red text is actually just info logging that we're not very interested in. A lot of this logging is really not very interesting logging for us, except down at the bottom. JPA has constructed a SQL statement that looks, oh, I've just lost it there, that looks something like this. Insert into employee, ID, job role, etc., some values. And the final line of logging looks very promising. It appears to be setting up the values 1 and engineer and Briggs and so on. It suggests, especially given there were no errors there, and oh, by the way, I can also see it's created the table up here as well. It suggests that automatically all of the required SQL has been issued. So I've switched back to the command prompt where I'm running the IJ tool, and I'm going to run again the show tables command, and let's have a look down the list, and there we are. There's now an employee table in there, and I can't wait to do this. Select star from employee. Again, if you haven't done SQL again, that will return all of the rows or all of the columns from the employee table. And well, it's not formatted very well because the line is too long to fit on the console, but certainly it looks to me as all the data has appeared in the database. Well, it took us quite a long time to get there, but only because we had to establish the concepts and create the config file for the first time. But we hope now that going forward with this, we're going to find it much easier to be able to create instances of classes and to get them into the database with relatively little coding. We've only got started with JPA. There's lots more to come, but that's probably enough for now. So that's a really good start with JPA. Still quite a bit to add, but at least we've got some data in the database. We've seen that JPA is an alternative API if you'd rather work at a higher level than the rather fiddly and tedious JDBC, which some of you may be already familiar with. JPA is based on a very successful open source library called Hibernate. You don't need to know anything about Hibernate to use JPA, but you're going to find after learning JPA that you're also able to use Hibernate. We had a look at what a domain class is. These are the classes that represent the objects in your system. For us, this is an employee, but common domain classes would be customer, client, user, order, item, and so on. For historical reasons, the annotation we need for the domain class is entity, and for this reason many people call the domain classes in JavaEE entities. I'll tend to use the two terms interchangeably. And we ended by persisting an object into the database via a single method call. So we're up and running, still quite a bit to do, and in the next chapter we're going to have a look at how to update and delete objects from the database. So I'll see you again soon.